Hello and good evening, everyone. My name is Siti Nur Hafizah binti Idris from Faculty of Electronic Engineering Technology. Today, I want to present a short review on synthesis methods of tin oxide as photoanode for dye-sensitized solar cell performance. Let me start my presentation with a quote. When energy is coming right from the sun, then why are we digging the earth? This quote means the sunlight is the most plentiful and safest energy source. The well-known device that related to the sunlight is solar cell, or also known as photovoltaic cell. This device converted the sunlight into electricity, and there are three generations of photovoltaic cells. My focus point is on the SSC, which is included in third generation. Here is the basic component in the SSC, which is transparent conductive oxide, usually used fluorine doped tin oxide (FTO) and indium tin oxide (ITO) class. For the second layer, there are metal oxide and dye sensitizer. Next is electrolyte, and last layer is counter electrode, which is the glass coated with a tin catalyst usually used carbon, platinum, or graphite. On the next picture, I will explain on working principle of the SSC. There are four main steps in this principle. Firstly is light absorption that happens in dye where electrons get excited from ground state to a higher energy state. Second step is electron injection where electron is injected into the conduction band of the semiconductor. Third step is transportation of carrier where the injected electrons are transported through the external circuit and reach at the counter electrode. Last step is collection of current where iodide is regenerated by reduction of triiodide. So, in the SSC, metal oxide or semiconductor or photoanode plays an important role in the SSC functioning. So, conditions that must have in photoanodes are large surface area, keep the photon loss to a minimum, exist conduction band less than LUMO, higher electron mobility, hydroxyl groups must be present, simple to make, stable, low cost, and environmentally friendly. So, why I choose tin oxide? This is because tin oxide properties almost fulfill the conditions as photoanode. There are also various of physical and chemical methods to synthesize the tin oxide nanoparticles such as sol-gel method, co-precipitation, spray pyrolysis, self-assembly, and hydrothermal. Here is the basic process for the sol-gel method. Sol-gel is a wet chemical technique involves several steps like hydrolysis, condensation, drying, and also crystallization. Next is for co-precipitation method. In this process, can get nano or micro particles by adjusting the pH, precipitating agent, temperature, and also solvents. Moreover, here is spray pyrolysis, which in this process a nanostructure is obtained when a solution containing a precursor is sprayed or injected using a nebulizer onto a hot substrate. Lastly, this is for hydrothermal process. In this process, the main apparatus used is autoclave, a stainless steel chamber lined with Teflon materials, and it used as heat treatment in this process. After synthesize the tin oxide using those materials, it will be applied in the SSC, and the SSC will be characterized to determine the efficiency. It will, it will be obtained by current density voltage curve, and from the curve, the essential terms are examined, such as open circuit voltage VOC, short circuit current density JSC, maximum power, and also efficiency, where it calculated using the ratio of maximum power to, to the total incident light power Pin. Herein the results of concerning the influence of tin oxide preparation on the efficiency of the SSC using the same die, ruthenium N719, which achieved in the range of 1.40% for hydrothermal method and the highest 3.96% by sol gel method. The impact of various factors in different synthesis methods of tin oxide are the structure of particles and also the size, solvent types used, immersion time of electrode in sensitizer solution, the roughness of electrode, and also the PV characteristics. In my conclusion, tin oxide is an attractive and reliable contender as a photoanode in the SSC application. There are various options for the technique in tin oxide fabrication, and different structures were formed and influenced the SSC performance. In my review, the sol gel method proved it could give the best performance to synthesize tin oxide and used as photoanode in the SSC. My last word is choose the best method so that you can get the best result. Thank you for your attention. And if you have any inquiries or questions, feel free to contact me at this email. Thank you.